we are going to start with prime factorization. Okay. And basically what this is breaking a number down into its prime numbers. Remembering that a prime number is a number that is multiplied by 1 and itself and has no other factors. Okay, so we're going to break a number down. So I'm going to pick an arbitrary number. I'm going to say 342. Okay, so you're given 342 and you have to figure out its prime factors. Okay, basically prime factorization is helping you remember your multiplication facts and or your division and division strategies. Okay, so we have to figure out how we can break this down into its prime numbers. So we have to look at 342. 342 ends with a 2. So what does that mean? Well, it means that it's an even number, and we know that all even numbers can be divided by 2. So I'm going to start with 2, and I always like to start with 2 if I possibly can. So I'm going to start with 2. So 2 times something is going to give me 342. So I might not know that off by hand, so I'm going to divide 342 by 2, and I can simply take my calculator, and then I can put that into the calculator, and I can go 342 divided by 2 equals, okay, 171. So then I'm going to come over to my tree, and I'm going to write 171. Okay, now I have to figure out, I have to continue this down because I haven't broken this number down unless it becomes prime. Okay, so if this number is prime, then I've broken it down. But 171, I'm going to see if I can divide something into it. Now, divisibility rules, which you have, or you will have, access to, you can look at that. So one of our strategies is to see if it can be divided by 3. I'll know a number is divided by 3 if I add up all the digits. So I'm going to take the 1 plus the 7 is going to give me 8, plus the other 1 is going to give me 9. 9 is divisible by 3, so that means that 171 can be divisible by 3. And if I take that and I divide it by 3, okay, and I pull up my calculator again, all right, I pull up my calculator and I take 171 and divide it by 3, that's going to equal 57, all right, so if I go back to my, so I just minimize this again, go back to my tree, all right, and I put in 57. Oop. Put in 57, 50x, 57. Okay, so then it's 3 times 57 will give me 171. 171 times 2 will give me 342. Now if I take this down again, I look at 5 plus 7 equals 12, and 12 is divisible by 3, so that means 57 can be divisible by 3. If I divide 57 by 3, all right, I'm going to get, look at my calculator, okay, I'm going to divide this by 3, all right, and it's going to equal 19. Okay, so in this case, I'm going to have 19. 19. Okay, so in this case, I've got all of the prime factors. Now, 19 is a prime number. I can't break it down, so I'm not going to go any further. And so therefore, if we look, 342, okay, in its prime factorization can be 2 times 3 times 3 times 19. And then we can combine that further because we learned about, or we will learn about powers. But we're going to put this as a power of 3, because 3 times 3 is the same as saying 3 to the power of 2. All right? And then times 19. All right, now I can double check that. If I go start with 0, and I multiply 2 times 3 times 3 times 19 equals 342. So therefore, the prime factorization of 342 is 2 times 3 to the power of 2 times 19, and that's how we do prime factorization. All right, so if I come down, and we can do a simpler one. If I simply take, well, let's try 100. All right, so if I do 100, I know 100 can be divided by a bunch of different numbers, but I'm going to start with 2 because that's the lowest prime factor. All right, and we know that 100 divided by 2 is 50. Then I'm going to go 50.
This is Rebecca McGregor. Please report to the cafeteria. Rebecca McGregor to the cafeteria.
Okay, divided by 50 divided by 2 is going to be 25. Now, 25 can't be divided by 2, but I bet you can figure out what it can be divided by. 5. And then 5. And all of these numbers here are all the prime factors of 100. Now, when we go to write out our prime factorization, we can write it out as 100 is equal to 2 to the power of 2 times 5 to the power of 2. Or in expanded form, 2 times 2 times 5 times 5. Okay, and you can do that with any number that's not prime into its prime factors. Okay, now on this side, if you keep your tree nice and organized, the numbers here will all give you the prime factors. All right, so this is a factor tree, and we're using it to find the prime factors. The purpose of finding prime factors is to really concentrate on your divisibility rules and also your multiplication facts. Okay, and this will help you in other strands of math.